Hello everyone, good afternoon. Warm greetings from Edureka. I'm Sonal Mittal and I have 16 plus years of experience in IT. And as you all know, Edureka has come up with this meetup and Edureka masterclass sessions for all of you, wherein you have different, Edureka is conducting different classes, different sessions by seasoned IT professionals. Okay, you can join the meetup group, which has close to 30,000 plus professionals all across India and world, wherein you can attend our webinars and workshops and live events, seminars that we conduct every other day monthly. These seminars, as I mentioned, are conducted by professionals who are into IT industry to keep you up to date with all the latest technologies and tools, my friends. Let us begin with Puppet. Before talking about Puppet, what is Puppet? What are the use or how to use Puppet? How to write Puppet programs? How to install Puppet? Let us talk about the basic, which is configuration management and why configuration management. So here you go, friends. Why do we need configuration management? I would like to break this term, that is configuration management, into two parts. Let us first talk about what is configuration, and then we will talk about how to manage your infrastructure, manage your configuration. Friends, configuration is nothing but packages. Okay. Before we talk about infrastructure, what is configuration? Configuration is if you have a machine. On your machine, if you want to install certain softwares, you want to create files, you want to give permissions to those files, you want to create users, group users, you want to create multiple directories, you want to start multiple services, install services, start services, upgrade packages. These are all called as configurations, friends. These are called as configurations. They're called as configurations. And friends, in IT or in our industry, friends, we just don't have one server. We just don't have one server. We have multiple servers. We have huge infrastructure, right? As you see in this image, there are huge number of servers in any organization that we work with, right? And configuring, that is managing the resources, components, environments on your servers, on all of these servers, managing their configurations, their components, their environments, their packages, okay, on all of these servers, so that any application that is running on this software, okay, any application that is running on this software can work seamlessly, is configuration management. Managing the infrastructure of your organization so that the application works seamlessly without any issues is configuration management. When I say resources, managing the resources, okay, when we say resources, we mean creation of users, creation of files, giving permissions, installation of packages, services, deploying your application, making changes to your application. If my mass deployment of your applications on entire servers, on all the servers in your organization, is configuration management. It is a hectic job if I have to do all of this manually. If I have to do all of this manually, okay, it is a really hectic job, friends. So what should we do? See here, an example is given to us. Okay, suppose there is an application. Now here we have a developer and we have two teams, right? In any project, friends, I'm sure everybody knows that we have two teams: development team and production team. Development team whose task is to create and implement new features. Production team, their task is to deploy the code into production servers. First issue that we always face is the code is working fine in the development environment, but when you give that code to your production team to deploy it on the servers, it is not working. The reason is environment dependency, friends. Environment dependency. In development environment, let's say we have a server. On this server, we have an application that has been created by this developer, and there is Java 8. For this application to run, we need Java 8. We need Java 8. Okay. The developer will give only the application package, the jar file, to the production team. He will not inform them, or with the application, we don't provide the underlying dependencies to the production team. But let's say in the production server, we have Java 7. We have an outdated and older version of Java, friends. An older version of Java is there in production, Java 7. I will deploy this application on Java 7. Will it work? Will it work? No, it will not work. Production team always blames the development team that your code is not working. But it is not because the application is not working, it is because the dependency is not correct. Right? It is an older version, or maybe Java 10 is available, an upgraded version is available. Then also your application not work. These are some of the configuration management problems that we face in real time. In addition to this, another problem that you will face is deploying the same infrastructure, deploying the same application on not only one server but multiple servers. Okay, so let us say you have to deploy an application, one application which is an HTML code. I will show you let me show you. I have a diagram prepared for it. One second. Suppose in my current environment, friends, I have four servers, friends. I have four servers in my current environment. On one server, I want to deploy my HTML application. Another one PHP. On third Python and fourth Angular, friends. For deploying all of these servers, for deploying all of these applications on different servers, what are the steps? I have listed them there. First and foremost, I will install HTTPD server. Right? On all the servers, I will install HTTPD. Then I will start the HTTPD service. I will also install Git because my code is available in the source code management tool. Right? Git is the source code management tool where our code will be available. Right? I'll have my HTML code and I will deploy my application on this server and restart HTTPD service. Same thing I'm doing on server 2 also. If you see till here, all under all the servers, same step, friends, same steps. Installing HTTPD, starting the service, installing it. And then we will pick up the code. We will pick up the code like PHP code we will pick up to install, to deploy that application on server 2. Python code we will pick up from Git to install it or deploy it on server 3. And Angular code we are going to take and deploy it on server 4. Right? Like this, if I have to do it for 100 servers, friends, if I have to repeat all of these steps for 100 servers in my infrastructure, isn't it time consuming? Performing all of these steps on a server is called as configuration, right? It is called as configuration. Managing all of these configurations on 100 servers or 200 servers in your organization is called as configuration management. Friends. It is called as configuration management. I hope now it is clear. Now, friends, when I say configuration management, it does not mean just installing the packages, deploying the application, but a configuration management tool, what else it does? It also ensures the desired state of the resources is also maintained, friends. Okay, suppose I want Java 7, Java 8 in all my servers. Configuration management tool will ensure that the same state of Java 8 is available in all the servers. In case there is a change in the state of the resource, immediately configuration tool will bring back the state. The desired state will be always maintained. Plus, friends, one more thing. Can we always go into our production servers and make changes? No, right? We cannot immediately go and delete a file or make changes to the packages on the production server. We cannot. We need to have proper approvals. We need to be the valid user. We need to have the correct permissions to make changes on our servers. Right? So configuration management tool makes a note of which user can make changes on this servers. It keeps a record of. It keeps the record of entire system state. Okay, it keep records of which user is installing, which user has made changes on your server. It keeps a log of when what changes were done, where the changes were done, and these changes impacted what applications on the server. It will keep track of all of this, friends. Okay, now another thing, friends, I was showing you a diagram in which we had multiple steps to be performed on each server, right, for deploying our application. Now, there were some steps which were common across all those four servers or 100 servers. There are steps which were common. Whenever we have repeatability, friends, whenever we have to repeat something, whenever we have redundancy, what do? Why not write code for it? Right? Whenever you want to repeat those steps, just run your code, same step will be executed on 100 servers. That is called as infrastructure as code, friends. Developers write code to create an application. Testers write code to manage the test designs. Now, operations or infra team will write code to manage their infrastructure. Provisioning of your dev environment, test environment, your production environment with the help of a code as I was showing in the example, if I write a code to install HTTPD, start HTTPD, okay, and install, deploy your application, install Git, get the Git repository. If I write a code for it and have that, maintain that code in my version control tool, run the code whenever I have to make changes to the environment, it will be very easy. I have to make changes to 100 servers or 200 servers, any number of servers. I just need to run the code. Where will we write this code? We will write the code in a configuration management tool, friends. Right? Where will we write the code? Using the configuration management tool, we will write the code and use the code to provide configurations on multiple servers, friends. So here, now friends, how is the approach for configuration? How configuration, whenever you write a code, okay, we have written a code. Our code is to go and install HTTPD, start HTTPD, install Git. These are the 3 steps in my code. Okay, when I write the code on a configuration management tool, how are they applied to all the servers? Here is a slide that I can present it to you. In any organization, friends, in any organization, you will have multiple servers, as we have already spoken about it. That is our infrastructure. So let's say I have 10 web servers in my infrastructure. I have 10 app servers and some 8 DB servers are there. Okay, we will always have one common machine, friends, which is called as the master controller machine. It is generally a Linux machine. This is the machine on which you will install your configuration management tool. You will install your tool here, and this is where you will also write your code. Your application, your configuration code will be written here, right? Infrastructure as code will be written over here. What installations, what configurations you want to apply on this servers. Okay, now once your code has been written on this master machine will be responsible to apply these configurations on all of these web servers and app servers. Servers will be connected to your master machine, friends, through SSH or SSL, depending upon the configuration tool that you are using. If you are using Ansible, the communication between the master machine and all your servers on the infrastructure will be through secured shell. If you're using Puppet, friends, the communication between your master machine and your web server will be through SSL certificates, friend. Okay, and there are 2 ways to apply the configuration. One is push, another one is pull, friends. Let me explain you both. Either you will have SSH or you will have SSL, and with SSL, that is with Puppet, you get pull, and with Ansible you will get push. What is push? Pull approach, let us see first. In pull approach, when if you are using Puppet as a tool, once you have written your code onto the master machine, the code will be as is. Let's say you have written the code at let us say I have written the code at 7 a.m. I've written a code at 7 a.m. to install Git, let's say, to install Git, or let's say to install Docker, any package, okay, on all of my web servers. On all of these set of servers, I've written a code at 7 a.m. okay, to install it on all of these web servers, right? When we are talking about pull, when we are talking about pull mechanism, friends, okay, there will be a time set. There will be a time set on the servers, that is every 30 minutes. Every 30 minutes, the servers are going to pull the configurations from the master machine. So that is at 7:30, all of these web servers are going to pull the configurations from the master machine, pull this code from the master machine and apply the configurations. Git will be installed here, 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 but when at 7:30. Let's say at again at 7. Meanwhile, around 7:45. Okay, you again write some configuration changes. That is, you want to create a file, create a file, create a file. Okay, so the next pull the servers will do, that is the slave machines, the slave servers will do at 8 a.m. 8 a.m. Okay, so between 7:30 to 8 a.m., if you have written any code, that will remain as is on the master machine. The next pull, the schedule that we have set is 30 minutes, let's say. It could be 15 minutes, 5 minutes, 30 minutes, one day, depending upon your configuration changes. Okay, the next pull is happening in our case is at 8 a.m. 8 a.m. again, the slave machines, the servers that we have, will pull the configurations from the master machine. They will request master machine saying that what are the configurations that I have to apply. Plus, at the same time, so the new configurations will be given. Plus, also the existing configurations will also be given. So here, the configuration tool will check the existing configurations, that is Git is available or not, ensuring the desired state. Secondly, the new changes will be applied. This is pull mechanism, friends. But pull is little bit, with Puppet we work with pull. But nowadays we have Ansible and other tools wherein we have push mechanism, friends. What happens in push, friends? In push, at whatever time you have written your code, let's say I wrote my code at 7 a.m., right? Immediately the changes will be pushed. Immediately the changes will be pushed and configurations will be applied to all your servers. You will provide your server details where the configurations have to be applied in your code, friends. In the code, you will provide the details of servers on which this configuration has to be applied. Okay, and push means immediately at the same time the configurations will be applied on the server as they are written. Master machine will be responsible to apply the changes to the web servers. In case of pull, the slaves will pull the changes from the master machine. Same thing here, friends. Push mechanism, central server will be there. Your nodes are your slaves of your server. Your infrastructure is called as a node here. Centralized server is pushing the configurations on the node. Okay. Whereas in pull, nodes will pull the configurations at period, at regular intervals, friends. Nodes will pull the configurations from the central master machine, friends. Okay. Configurations will be applied once the slave machine pulls the changes. Okay. Central machine will not push the changes to the node in case of pull. So Puppet here that we are going to see today uses the pull mechanism, friends, pull configurations. So different continuous configuration tools are Puppet, Ansible, Shelf, and SaltStack. Whereas SaltStack is a paid tool. Puppet, Ansible, Shelf are freeware tools. Puppet, Ansible are freeware tools. You can download them and use them, friends. Puppet uses pull configuration. Ansible uses push. See here, SaltStack also uses push, whereas Chef uses pull. Now, what is Puppet? Let us exclusively talk about Puppet now, friends. Puppet is a configuration management tool that will actually mass deploy your application, that will install packages, that will create files, that will manage your servers, that will manage the configurations on your server, friends. Okay, and Puppet works on a master and slave architecture, friends. In Puppet, on the master machine, so we have two things, friends, in Puppet: Puppet master and Puppet agent, friends. One machine, one Linux machine you will take, you will install a package called as Puppet Master on it, making it as a master machine, friends. This is where you will write all your configuration code. Then other servers you can take and you can make them as your slave machines. And on the slave machines, you will do the separate installation of Puppet agent, friends. You will download a package called as Puppets on it, okay, which will install a process called agent on all your slave machines. The agents and masters are communicating through SSL certificate, friends. Secured socket link, friends. They will communicate with each other only if the secured socket link is set up is done. Okay, so we can do it manually, friends. Set up between the master and the agent. Okay, configurations are pulled from the master by the agent machines. Puppet works on the pull configuration. So let us see the architecture. It's a very interesting architecture. Please listen to it carefully. Puppet master and slave architecture. Okay, what happens in Puppet, friends? Here you go, friends. First, you will have two machines. One machine on which I have installed Puppet master package, making it as my master machine. Then you will take one more machine which will be called as your slave machine. On this machine, you are going to install. On this machine, you are going to install your package called as Puppet agent package, friends. Making this as my slave machine. So this is my slave machine, and this we know is our master machine. Once the slave machine is set up, friends, they both will communicate with each other. You will first step that you have to do is SSL certificate you have to set up, friends, between them. SSL communication between the two machines should be done. Okay, so that all data can be transported between the master and the slave machine. As the SSL certificate setup is complete, node machine, the slave machine, will send facts to the Puppet master. What are facts? Puppet. So on the Puppet agent machine, there is an agent process which is running, right? It will calculate, it will collect all the node facts. Facts as in what is the OS family of the node, what is the CPU of the node, what is the IP address of the node, what is the host name of the node, memory information, BIOS information, network, MAC, mount points, complete information about the node. It will calculate, it will collect, not calculate, collect, and prepare as a file and send it to the master machine. On the Puppet Master, these facts will be stored friends. Why do we need these facts? Using these facts only, Puppet Master will create a catalog friends, will compile a catalog. What is the catalog? Catalog is a file compiled by master machine using the facts sent by the node. That is, let's say the node is a Red Hat Linux node. On this Red Hat Linux node, I can install HTTPD. If the node is Ubuntu, let's say the fact says the node is Ubuntu, I cannot install HTTPD. I will install Apache on. Right? The package name changes. So based on the facts, we will do the configuration. Right? Master needs to know what kind of slave it is. Then I will apply the configurations on it. Right? Okay, so based on the facts, Puppet Master will write in the Puppet Master. We will write code. It is called as a Puppet program, or we call them as manifest files in Puppet. Manifest files in Puppet we call them friends. These manifest files plus the facts plus your facts. I will show you both. Okay, your manifest files plus your facts together form a catalog of friends. Puppet uses the facts to compile a catalog that specified what should be configured on your node. Where will you define what should be configured in your code? That is called as Puppet program, or you can call the manifest file. And based on the facts, what type of node it is, which network is it running, I will define the configurations. This catalog will be on the master machine, friends. This catalog will be on the master machine, and node is going to pull this catalog, friends. Node will pull the catalog at desired interval, 30 minutes, 15 minutes, every 5 minutes it will keep pulling the catalog. Will keep pulling the catalog. Even if there are no changes in the catalog, the slave machine will pull the catalog, and the agent process or node will apply those changes to ensure the desired state of the configurations are met. The disadvantage here is, friends, let us say your configurations in your infrastructure are not changing often. Maybe once in 15 days you are making changes to your application. Configurations are not being changed very often. But in the node, you have set up that every 30 minutes, pull my catalog and apply the configuration. But changes are happening only in 15 days. For unnecessary, for every 30 minutes, node is using its resources to pull the catalog, apply the catalog. Right? Because if on your node there are continuous changes happening, configurations desired state have to be maintained, then yes, set the interval for a frequent interval to pull the catalog. Otherwise, you can set the interval to be 15 days, every 1 day, every once a week, pull the catalogs and check that, ensure that the desired state is okay. All right, so this is the architecture. Plus, after that, friends, once the catalog is pulled and changes are applied on the node will send a report back to the master saying that my configuration is complete. You can check the changes on the Puppet dashboard, friends. You can check the changes on the Puppet dashboard. This is the Puppet master and slave architecture, friends. Okay, so same thing here. Puppet slave, Puppet master here. First, you will send a request for setup of the certificate. Then it will send back to the master. Master is going to sign that certificate, send it back to the slave. Communication will start. After that, communication will only start. Request for certificate. Master will send the certificate to the slave. Slave will and master will also request for the slave certificate. Slave will send its certificate. Once the certificate is signed by the master, Puppet slave can send the facts to the master, and master can send the catalog to the slave. That's how the communication happens. Okay, let us do the architecture setup, and then we will see how to deploy our applications here. Okay, let us see. We'll write a Puppet code also. Let me just first set up Puppet for you guys. Meanwhile, I'll connect to two machines, friends, two Linux machines. One machine I'm going to make it as Puppet master. Another machine I'm going to make it as Puppet agent. Let me just quickly connect to two machines. So I've created two AWS instances, friends. I've created two AWS instances. One is going to be my master, Puppet master. Another one is going to be my Puppet agent. Let me just change the color of this so that it becomes my Puppet. You know that it is my Puppet agent. Okay. This is my Puppet agent. Let me start this machine. I'm just showing you how to do the setup for Puppet Master and Puppet Agent. Quickly, I'll show you. And then we will write a Puppet program. So on Puppet Master, friends, on the main master machine, you will install a package called as Puppet Server, friends. Puppet Server. And on the agent machine, that is on the slave machine, you will install a package which is called as Puppet, just Puppet, making it as an agent machine. Okay. So first we will take up the master machine. On this master machine, we will first go to vim etc host, and in this machine I'm going to add the private IP of both my machines. Take the private IP of your master machine, place it here in the host and the private host name. Same thing you are going to do it for the agent machine also, the slave machine. Okay, we will copy this because we have to do the same changes on the slave machine also. Save this file. After this, go to the same your slave machine also. Go to the same file there. Insert the same details there also. After this, we are going to install Puppet. Okay, so for that we will first install the Puppet package, friends. We will first install the Puppet package, and the part for that is you can download the Puppet package from this link. Let me execute this package. This will install Puppet for us. Now, using this repository, I'm going to install Puppet Server, friends. The package that you have to install on the master machine is called as Puppet Server. So yum install Puppet Server. The important thing that you have to remember, friends, Puppet basically follows a strict directory structure. You will see that when I will show you the demo. Okay. First, we will install Puppet Server on the master machine. Once you are done with it, we have to just go and update the Puppet config file. You will go to etc Puppet Labs. Puppet. There is a .conf file. Go to this file and add your master machine. That saying that this is my master. You will add the DNS alt names of your master. So take the private host name of your master, private host name of your master, and add it here. This is the location where Puppet log will be available. And if I show you log dir, this is the location where all your Puppet facts, the agent will send you facts, right? That will be all stored at this location. Okay. DNS underscore alt underscore names is equal to your host name you have to provide, the private host name of the master. This configuration is done. After that, one extra configuration I have to do it because I'm using a cloud machine, which is a small configuration machine. So I'll just go and change some system configurations there. Sysconfig Puppet server. In this, Puppet server takes some Java arguments to run. By default, it needs 2 GB of memory, but I don't have that many resources, so I will change it to 512 MB in the configuration file. That's all, friends. Our Puppet server setup is complete. Just restart the machine. Restart the machine. Okay, restart the machine, and the setup will be complete. After this, let us start systemctl start Puppet server. So it will take some time to start the Puppet server. Meanwhile, let us go and do the setup for Puppet agent also. On this also, we are going to install the same Puppet package first. We will take the same Puppet package, and also we are going to make changes on the conf file. So we are going to go to the same vim.hc Puppet Labs. Just for information, Puppet Labs is the official site of Puppet. Okay, and go to puppet.conf file. Did I open the wrong file? I think. Vim. Okay, sorry, we didn't install the package, right? So let us install the package. Yum install. Before installing the package, I was just going to this configuration file. Here we will just install a package called as yum install puppet, friends. That's all. We will just install Puppet, which will automatically start a process called as Puppet agent on this slave machine. Complete, friends. Now let us go to this file. In this file, it is the same file on master and slave, but you see the content is slightly different. Here we have to set up, we have to give the server details. Okay, what is the my server private host name? Okay, done. After this, just restart your server. Okay, and now let us see if the Puppet master is ready. If the master, yeah, Puppet server is started now, then you can even start the Puppet agent also. Systemctl start Puppet agent. Done. Now friends, the setup is complete. Or Puppet master is ready, Puppet agent is ready. Can they communicate with each other? Let us see. Let us try to pull the configurations from the master. So for that, if you want to manually pull, by default, the time is set for a slave to pull from the master is 30 minutes. You can also manually pull the configurations using this command, puppet agent test. See here, no certificates are available. That's why communication between them is not set. We have not done the SSL certification setup between the master and agent. So for that, we have to go to the master machine, sign some certificates. First, look for certificates. Puppet, okay, cert list will give you all the certificates that are on this particular master for all the slaves that we have connected. So there is one certificate here. There is a certificate here, right, which is not signed. If it is signed, you will get a plus sign here. This is the certificate of my slave machine, which is not signed yet. So let us sign this certificate. Once you sign the certificate, the communication between the slave machine, that is the agent machine, okay, and the master machine will start. So for that, the command is puppet cert sign. Done, friends. Now if you see all the certificates, they are available. Certification has been signed. Try to pull the configurations from the agent machine. It will now pull the catalog. See, caching the catalog, applying the catalog, but we don't have anything in the catalog right now. We don't have anything in the catalog right now. So it did no configurations done so far, but it was able to pull the default catalog. Default catalog it was able to pull. Now let us write some program. Let us write some configurations and apply it on the slave machine. Let us do that. For writing the configurations on the master machine, we will use manifest files, friends. Manifest files are Puppet programs wherein you will write your configurations to install packages, start services, deploy your applications. These manifest files, along with the facts, are pulled by the slave machines to apply configurations on themselves. Okay, so where do we write these manifest files? For us to write the code, okay, Puppet strictly follows a directory structure. So you will go to this directory, Puppet etc, Puppet labs, code. Okay, you want to write the code, right? So we have a separate directory here in Puppet, environments. Okay, here you will have production. You can write code for production, for test environment, for dev environment. You can write and manifest. Okay, let us go to this directory. In this directory, right now there is nothing. Let me just 1 second. Yep. In production, let me show you some directories. We have directories like manifest and modules. Modules, you can assume like methods in programming language we have, right? So we define classes and methods of Puppet program. It's a code, right? You have to write so classes, methods. I hope you can relate it to programming language. You will write everything in modules. You will call these modules in your manifest file. That is go in manifest. In manifest right now there is no file. Let us create a Puppet program. Then I'll give a file name as site.pp. pp here means Puppet program. I'll use Vim editor to write a Puppet program. Inside the Puppet program, you will first give the node information, the node on which we want to apply the configuration. Okay, so the node on which I want to give apply the configuration is, let me take the host name, okay, of this particular machine. This is the host name of this agent machine. Take the host name of the agent machine, provide it here in single quotes. Okay, here, done. Inside this, friends, in the manifest files, we write something called as resources. Resources are small Puppet programs which are already provided by Puppet, like user-defined methods that we have in Python and Java. Right? Similarly, in Puppet also we have resources which are already provided to us by Puppet community. You call those resources, apply, and your configurations will be applied on the agent machine. In your manifest file, we will call those resources. Let me list you some resources. Let's say there is a resource called file resource. File resource and brackets is important, friends. In Puppet programming, brackets are important. Okay, opening bracket and a closing bracket for the node. Whatever you will write inside the node, whatever resources you will write inside the node will be applied on this particular node. It is called as a node definition also. Okay, now let's talk about the file resource. File resource in Puppet is used to create directories, create files on your agent machine. Okay, the name of the resource is file. After that, you will open in a bracket. This name is already defined in Puppet. I am not writing it. File is the name. Now I will write my custom path where I want to create a file. Let's say in the root directory I want to create info.txt. Okay, I want to create a file info.txt in the root directory of my agent. Okay, then you will always give a semicolon. After that, we will give some parameters. Where should the file be present or should the file be deleted? So you will use a parameter called ensure, separated by fat commas. Okay, you will use the parameter, separate them by fat commas, and you will say ensure what is the data present, and so ensure it is present. Okay, and let's say you want to add some content also into the file, content. Okay, I'll say file from Puppet Master, done. Okay, file from Puppet Master, done. End it with the semicolon. After every parameter, we will give a semicolon and close the brackets. You're closing the brackets for the file resource. Isn't it like a small method, like a small module in Python program or Java programming we have, right? In the bracket, you will provide the name of the resource. Okay, what you want to create a file or you want to delete a file, you will provide it with a parameter and content. You want to give some permissions. You can write your resource details based on the parameters that we have. You can go to Puppet Labs, so you can find all the resources related to Puppet. Okay, so this is a small resource that I have written which will be applied onto this node, a small configuration which has to be applied on this node. Let me save this and see if this configuration can be applied to my agent or not. Currently in my agent, let me see in the root directory, do I have info.txt? No, there are no files here. Okay, sorry, I'm not in the root directory. Here, Do I have info.txt? Not there, friends, not there. Okay. And I told you puppet agent works on full configuration. I have the configurations here. Okay. But agent has to pull these configurations. Agent has to pull the catalog for us. Okay. So for pulling the catalog, we will execute the same command, puppet agent test command we will execute. Okay, to pull the catalog, it will pull the catalog, and these configurations, whatever configurations we have mentioned inside .pp will be applied. See here, friends, I pull the catalog, applying the configurations. What configurations have been applied on this node? A file with the name info.txt is created, and this is the content of the file. Let us see. You are in the root directory. See here, info.txt has been created, applied. See the contents of info.txt. They are available. File from Puppet Master. Right? Let us go and write one more configuration. Here I will write one more configuration, friends. Let us install some package. Let's say we will install a HTTPD package. Okay. So the resource name in Puppet is package resource only to install any number of packages. Okay. So I'll write HTTPD here. End it with a semicolon. Ensure it is present. Okay. And that's all. We don't need to give any more information. We just want the HTTPD package to be available. Another thing, I want to start also HTTPD. So I will say service. It's a service, right? We need to start the HTTPD service. Done. Ensure service is running. Okay, service is running. So when we save this file, automatically agent will pull these configurations, install HTTPD, start HTTPD for us on the agent machine, and enable is true. Okay. So what you have to learn from after today's session, if you are interested in learning configuration management tool and that to Puppet, you need to learn these resources first. You need to learn these resources. What are the different resources? What parameters goes inside these resources? How to create this node definition file? How to create node definition file for multiple agents? Okay. Alright, let us save this. You can also validate this file using Puppet parser validate site.pp to see any validation issues are there or no validation issues. Let us pull the catalog. So you will use Puppet agent test. Sorry. So it is going, see here, there is an error, evaluation error, server, there is a resource site.pp, on some resource there is an error, line number 13, unknown resource type server. Let us go and see service, it is, I gave server, I think. Let us go to the site.pp file, service it is. The name of the resource is service. Service. Pull it again. See here, both the configurations have been applied. HTTPD has been installed and it is in the running state. Earlier it was in stop state. It has been changed to running state. Systemctl, you can check it. Status HTTPD service. Active and running. So this is how you can apply your configurations not on just one machine, multiple machines at a time. If I make in this site.pp file only, if I create this node definition file and I add all the node details on which these three configurations have to be applied, just by writing this one file, okay, all the servers, I will automate this process of pulling the catalog. I will not manually pull the catalog. In real time, we automate this process. We set the run interval to, let's say, every 30 minutes, 5 minutes, and automatically all the servers will pull this catalog. We just have to ensure we prepare this site.pp is available. Okay, right? So I'll stop here, friends. I will start the demo here. Let us continue in those slides if we have any. Now Puppet here, friends, if what I have shown you, I've shown you how to create a manifest file. I've spoken about resources. We also have classes and modules in Puppet friends. Classes are nothing but which consist of set of resources. Okay, so instead of writing individual resources as we wrote here, we wrote single resource, right? Single resources like this. We can create a class. In that class, we can write all these resources. In the node definition file, just to call your class. Just to call your class. Okay, this way you can have multiple nodes and you can just call the class in it. All the resources will be applied. Where do you specify the auto name? On the agent machine. On the agent machine, you will go to the configuration file. In the agent machine, we will go to the configuration file and we will set the run interval in seconds. You will set the run interval in seconds. You will go to the configuration file puppet labs slash puppet slash puppet.conf. There you will add one value called run interval and the time that you want to change. So modules is where you will write your classes. In classes, you will have your resources. In the manifest file, you will call your classes. Code basics we have seen. I've already shown you. Resource, you will write your resources in the classes. Then you will have multiple manifest file. You will call your classes in the manifest files. Modules is where all your classes can be written also. Okay. See these different resources I have just shown you. Right. I have taken different resources like file resource. This is the name of the file that we gave. Ensure it is present at this location. Right. You will give the resource type, resource name, its attribute. It's similar to that of class. Then in classes, how you write class name followed by resources. Here, class, name of the class followed by the resources in it. Okay. What is a module? If I have to tell you, module is basically set of folders, friends. You can segregate, okay, your library folders, your manifesto folders, your metadata folder, your variables folder, your files folder, and place each thing separately in a separate directory. Better organizing your code, friends. All right, friends. Thank you so much. Good day, friends. Good day. Bye bye.